Have you at any point analyzed whether we're really alone in the universe? Then again, on the off chance that there's another thing to our world other than anything that we see, imagine a situation in which the James Webb Telescope finally shows that we live inside a black hole. Join us as we sort out more about this world, spreading the word that will make you question everything you thought you had some comprehension of the universe. So, what precisely are black holes? They're similar to something out of a thriller. Sure, you might have seen them in sci-fi films, but what's even more disturbing is that they're not just as shown by educated authorities. Totally black holes in space are actually enormous concentrations of matter squeezed into an unbelievably small region. Think about a star, many times more massive than the Sun, all packed into a region the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for a long time. They studied objects in space so gigantic and dense that they could trap light. The most prominent ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes is no easy task since they emit no light. However, researchers have found ways to unravel their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get destroyed, emitting X-rays as it does so. Black holes also affect their surroundings. They can consume neighboring stars, produce strong radiation beams, and even influence the formation of new stars in certain regions, while suppressing star formation in others. But how do black holes form? Picture this. Stars, once brilliant and shining, meet their brutal end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, tiny stars, when they die, transform into something many refer to as neutron stars, which are incredibly dense, but not dense enough to trap light. If a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these massive stars collapse, something extraordinary happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last crucial point for anything falling into a black hole. The star's clock ticks at a different speed compared to our own. Occasionally, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, they create a titanic nightmare that defies understanding. Scientists have been grappling with the scale of these immense phenomena for a long time. Black holes come in two sizes, massive and small. There's a deceptive mystery surrounding them that we can't ignore. However, small is relative when it comes to black holes. Supermassive black holes, remnants of massive stars, can be as much as 10 billion times the size of the Sun. There may be as many as 10 million to a billion of them in the Milky Way alone. That's an enormous number of black holes that could swallow anything in their way. But wait, there's more. Some supermassive black holes are at the outer limits of the spectrum. They're millions, if not billions, of times larger than the Sun. They exist at the center of massive galaxies, including our own Milky Way. It seems like a vast, dead space that is pulling everything toward it. Famous physicist Stephen Hawking talked about black holes throughout his life. His theories were largely well-founded, but some of his ideas proved difficult to verify due to a lack of relevant technology. Yet there is hope on the horizon, not too far away. A single revolutionary instrument is changing all that. It goes by the name of the James Webb Space Telescope, or JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human creativity. Sure, we've launched other space telescopes before, and they've been doing their jobs competently, But this incredible machine is on a level that's truly extraordinary. The JWST makes the Hubble, which has served us for decades, look like a simple toy in the universe. The retail cost of this cosmic wonder is a staggering $1 billion. Yes, you heard that right. That's a jaw-dropping number of zeros that'll make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this miracle to life, along with significant contributions from over 300 universities. But we mustn't forget the risks that come with such a monumental undertaking. This isn't a task for the faint of heart. The JWST is venturing into uncharted territory, pushing the limits of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission lifetime. Since its launch, the JWST has achieved several stunning milestones. It traveled over 1 million miles to reach its orbit around the Sun, where it will dwell indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and enormous primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, NASA has adjusted and calibrated it, and the telescope is essentially ready for full operation. Perhaps one of the most exciting aspects of the James Webb Space Telescope was when NASA announced it had captured its first scientific images of starlight. The first picture taken by the telescope was of a star called HD 8446, revealing a few scattered bright spots from the star's light gathered by the 18 mirror segments on the primary mirror. NASA later released another truly spectacular image of HD 8446, where 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory calibrates the individual segments of the primary mirror, it will begin the image stacking process, overlaying the 18 images into one clear view. Thanks to its advanced technology, the JWST will assist scientists in exploring the early stages of the universe, shortly after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This epoch refers to when neutral hydrogen was reionized, or given an electric charge again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help researchers discover exoplanets, which are extremely difficult to detect due to their interactions with their host stars. Strong observations can certainly detect these planets more closely, allowing scientists to analyze their atmospheres and assess the conditions necessary for life. The JWST's capabilities will also help experts better predict whether certain planets are habitable. Aside from focusing on the formation of galaxies, scientists study galaxies to understand how matter is formed on a massive scale. This, in turn, helps us comprehend how the universe evolved. The spiraling and twisting galaxies we see today were formed over billions of years from various shapes. One of the JWST's goals is to look back at the earliest galaxies to better understand that evolution. Researchers are also working to determine how we arrived at the combination of galaxies that are visible today and the ongoing processes through which galaxies form and accumulate. At its core, the James Webb Space Telescope will help us answer some of the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt. And guess what it has found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures appear to be the goth of the universe. They're found everywhere, from distant galaxies to comets in our solar system. Now, they're not just intriguing because they could form the building blocks of life, but also because they help scientists track star formation. When bright radiation hits these PAHs, they become energized and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, known as MIRI. Moreover, that's generally a sign that there are some hot, energetic stars nearby. But here's the astounding twist. A daring astrophysicist, Ismael Garcia Bernard from Oxford University, decided to study 3 fascinating galaxies, NGC 6502 and GC 731, the eerily striking Stephan Quintet, and NGC 749. These galaxies are many light-years away in the depths of obscurity. Now, what Garcia Bernard found will make your hair stand on end. In those central regions where the black holes dominate, he observed an abundance of PAHs. Sounds interesting, right? Well, here's where it gets chilling. The radiation near those massive black holes altered the PAH's very composition, transforming them into larger, electrically neutral forms of themselves. The smaller, electrically charged PAHs vanished into obscurity, consumed by the very darkness. This discovery raises fascinating questions about the interplay between the most extreme objects in the universe, black holes, and the very building blocks of life itself. The transformation of these PAHs near black holes hints at an even deeper connection between the formation of stars, the evolution of galaxies, and the possibility of life beyond Earth. What Garcia Bernard uncovered could be the first step toward understanding how the ingredients for life might form in some of the most hostile and extreme environments imaginable. As scientists continue to unravel these cosmic mysteries with the help of the James Webb Space Telescope, we are also coming closer to understanding some of the most profound questions about our place in the universe. Are we alone? Is there life elsewhere, perhaps thriving in conditions we might once have considered inhospitable? Could the universe itself be a much more complex and interconnected place than we ever imagined? The answers may lie far beyond the reach of our current knowledge, but with instruments like the JWST, we are slowly but surely unlocking the secrets of the cosmos. From black holes to distant galaxies, from the birth of stars to the potential for life on other worlds, the journey of discovery has only just begun. As we continue to peer deeper into the universe, we may find that not only do we live in a far more mysterious cosmos than we realized, but that our understanding of the universe is only a small part of a much grander, more intricate picture. The JWST represents not only a monumental achievement in space exploration but also a bridge to our future understanding of the universe. With its unprecedented capabilities, the telescope promises to expand our knowledge of the cosmos and to potentially answer some of the biggest questions humanity has ever asked. What are the true origins of the universe? How did life begin? Are we truly alone, or are we just one small part of a larger, interconnected cosmos? These are questions that will take time to answer, but the future is brighter than ever. With each new image captured by the JWST, we are inching closer to understanding the universe's vastness and complexity. So, as we continue our exploration, let us remain curious and excited about the possibilities that lie ahead, for the answers we seek may be closer than we think.